Martinez with the demo for the part 1 for project 2. I wanted to go over my main to explain how this is working. So first we have the PLL init, which initializes the system clock to 80 megahertz because the division is 4. And then we have the UART initialization, which essentially initializes UART 0, which is the one that's able to communicate between the microcontroller and the computer serial communication terminal, and that is located on port A, specifically port A1 and port A0, which are alternate function and digital, and we disable analog down here. The baud rate is set to 115,200, which is fairly fast, I believe, and is able to give us the communication we desire. Then we have the SysTick init, which is just the initialization, and up here in the SysTick handler we have the reload value. So we have a reload value of about 40 megahertz, which is fairly quickly again, in order to give us fast communication. And we have the port F initialization, which is setting inputs on for the switches, switch 1 and switch 2, which is port F4 and port F0, and then it's setting the LEDs as outputs, which is port F3, 2, and 1. Then we enable interrupts, and we set a couple constants here for the initialization of our code. So to explain what's happening here, we are first reading input from the switches. So switch 1, we're going to look for when it's pressed down, and the same thing with switch 2. And then immediately after, we're using a non-blocking incharf, or the UART, which won't wait for input. It'll essentially look, see if there's an input, and if not, it will continue with the code. That way we can easily flow and not stop everything running right there. So then after that, we have different cases for when switch 1 is pressed, and I made this constant called off, which will essentially tell me if the light, if it's set to 0, I know that it's currently on, and if it's set to 1, I know that it's currently off for the LED values. So I have these constant, every single time that we go into one of these cases, I set last to be equal to a value here, and then from there on I take out the out string and then output the LED values that I want. And for example, in this one, I set off to 1 because previously off was the LEDs were on, right? So then the next time that I go through and click that button, I want to make sure that it goes into a different variable down here. Yeah, so it would be just to let, where is it? It would go down here when the LED is pressed, letting us know that the value is going to be turned off when it's pressed. So to show, it's kind of the same with all the other ones, except these ones take as an input for the keyboard. It takes it in, and then it has the same logic that if it has been pressed before, it will turn off. But if I go ahead and I just switch from case to case, it will output just the LED instead of turning it off. So that might be a little easier to explain how it's working here. So I have the serial terminal here, and I have the microcontroller. So currently everything is off, and if you see, if I go ahead and press R, it will give me a red LED, and then in the terminal it says red LED. If I press G, it'll be green, and if I press blue, it'll be blue. Now there's also the case that I press the switch buttons here, which will turn all the LEDs, so it turns white and it gives me the message over there. And the other case where this switch is pressed, LEDs are all off. So the other case that I do have is if I have the red LED on and then I press R again, it will turn it off. And then I can go to the next one, turn it off, B, turn it off, and every single time it tells me in the terminal that it's working. And same thing if I have this LED on and then I press turn off all over here, it will turn them all off, or all on and all off. So yeah, that's essentially the bulk of it, and I will get part 2 to you pretty soon. Thank you.